Welcome back to another Pigeon Power production. We are continuing where we left off with problem A2 of the 2020 Canadian Open Mathematics Challenge. So without further ado, let's start. As we can see, but in this problem statement, we need to check how many of these 24 four-digit numbers are divisible by 4. But before we need to do that, we need to figure out what these numbers are. I didn't come up with a smart or efficient way to figure all of these numbers, but fortunately, as the problem says, there are only 24 four-digit numbers. So, if you have done problems like these before, you shouldn't have a problem listing them all. But if you do, and you haven't really done problems like these before, I would suggest that you start off with 1,234 and work your way up from smallest to largest. I'm actually going to leave a little bit of time for you to try and figure this out. Make sure to pause if you want to try this out yourself. Now that we have all the numbers, we could very easily just check each number individually. However, one tip I live by is, if something seems to be repetitive in a math problem, you should probably consider finding a more efficient approach. One of these approaches is something called Modular Arithmetic, which is a fundamental topic in contest math that I would advise you to learn because it's very helpful in later math contests. Now, I don't have all the time to go through everything in Modular Arithmetic, and if you want to find out more about it, then you should check Khan Academy, or you should buy Art of Problem Solving's Volume 1. But if you don't have the time for any of those, I'm just going to explain here the one principle of modular arithmetic that we will be using in this problem. So let's say you have three numbers, x, y, and m. According to modular arithmetic, if the remainders of x divided by m and y divided by m would be the same, x is congruent to y in modulus m. Now, if this starts to sound confusing to you, let me give you an example. Let x be 13, y be 8, and m be 5. 13 is congruent to 8 in modulus 5 because 13 divided by 5 is 2 with remainder 3, and 8 divided by 5 is 1 with remainder 3. 3 equals 3, which proves our point. Now, it is worth knowing that x minus y, if it's divisible by m, then x is congruent to y modulus m. And now that I've explained a bit about modular arithmetic, since we are searching for numbers that are divisible by 4, we are really only concerned about the remainders of all these numbers when divisible by 4. We don't really care about anything else, such as 4123 ends with 123. It would be really convenient if we could get a number such as 4312 to a smaller number that we can work with easier. Where can we find an x minus y in each number here? What numbers that are always divisible by 4 can we find in each number so that we can repeatedly subtract from them until we get an easier, smaller number? Oh, 100. Since 25 times 4 is 100, 4,312 would be congruent to 4,212, which is congruent to 4,112, and so on. We can keep doing this with every number until they are all congruent to two-digit numbers. Each one of these numbers, the 34, the 43, the 24, represents a number that the original four-digit number was congruent to. It might be confusing that numbers like 34 are repeated. In fact, every one of these numbers are repeated, but they still represent a different number. You might think, at this point I can just manually divide everything by 4. And you could, but there's one more way of making this problem solving more efficient. Since 4 equals 2 times 2, every number that is divisible by 4 would be divisible by 2. And every number divisible by 2 has to have an even digit 0, 2, 4, 6, or 8 as its last digit. And since 4 is 2 times 2, every number will need to be ended in an even digit to be divisible by 4 as well. We can eliminate more numbers here. At this point, there isn't really a reliable way to make it more efficient, and we can just manually divide by each number, which is much easier. There are 6 such numbers that are divisible by 4. And there we have it. There are 6 numbers that are divisible by 4. For our double check, we can just divide everything manually. For the sake of this length of the video, I won't divide through everything, but I'll just show you that the 6 values that were divisible by 4 are actually divisible by 4, and you can find this out without using modular arithmetic. I have just included the principles to the left if you wish to review them. Anyways, thank you for watching my video, and stay tuned for problem A3.